So this Gen AI or generative AI, as just now told you that generative AI mainly used to generate some content. We can generate content like image. We can generate content like audio, video, code. So as the name of generative AI is saying, that we want to generate some content that is generative. So the prerequisites for this Gen AI, the content for this Gen AI that we'll talk about in this curriculum is that first we'll talk about some AI/ML introduction, because there may be different category of participants. We want bring all the participants on the same page. Some participants maybe already know some basics of AI/ML, but some participants may be from some other background. So based on all participants' point of view, first we'll talk about some AI/ML introduction. Then we'll move with the deep learning introduction, because deep learning is the core of our Gen AI. If you go to the internal architecture of generative AI, you'll find there is different types of deep learning is being used internally. So before coming to Gen AI internal architecture or Gen AI basics, we'll get good understanding about deep learning introduction. Then we'll move with generative AI introduction, right? Because generative AI is completely connected with basic AI/ML as well as deep learning. Next, we'll talk about one of the very good and popular product. Its name is ChatGPT. It is one of the Gen AI example, and it's created by OpenAI. It is one type of Gen AI LLM. We'll talk about them. Next, we'll talk about prompt engineering. When I go with the Gen AI, prompt engineering is very important a part of Gen AI, because it is used to retrieve the content from the LLM or from the Gen AI product. We'll talk about in details. Next, we'll move to generative AI with cloud. So because of the popularity of Gen AI, especially its popularity started with OpenAI products, ChatGPT. Different cloud came with their Gen AI solutions. You'll find Gen AI solution from AWS, Gen AI solution from Azure, Gen AI solution from GCP. We try to understand the Gen AI solution from different cloud. We'll explore them. We'll do hands-on. We'll see how different cloud Gen AI products work, and we'll suggest you to do the hands-on on the other side simultaneously. Next, we'll talk about the generative AI internal architecture. That is the point, once the, as an employee today, as an employee, it is recommended that everyone should know Gen AI. Just 10 to 15 years back, it was the scenario like, everyone should know Java, something like that, right? Same like that today, based on the current industry requirement, it is recommended that everyone should know Gen AI basics. That does not mean that everyone can work as a developer in the Gen AI domain. So if you want to work as a core developer in the Gen AI domain, then we should have very good understanding about AI, ML, deep learning. Then only, you can create some product, in the Gen AI industry. The two categories there, right? So if you go in depth of Gen AI internal architecture, mainly it is based on transform architecture. You'll find lots of deep learning models being used. Each and every deep learning model has its own advantage, disadvantage that we try to explore when you go with this internal architecture of generative AI. Then we'll move to generative AI as an LLM, RAGs and RAGs plus. See, generative AI internal architecture, when you go, you'll find that generative AI products have some limitations. Like Gen AI product, like LLMs, they'll not give you real-time update. So some limitations is there in Gen AI product. So to resolve that limitations, we'll find RAGs. RAG plus. We'll try to explore what are the limitations of GenAI product and how it is being resolved with the help of RAG or RAG plus. And industry is using that today. And try to implement good lab example related to each topic, right? So this is our course content that we're going to cover in this curriculum. So let's move with this content one by one. As I just now told you that with GenAI is a very good and excellent module. And but it has some prerequisite. So we try to explore the prerequisites initially. And I'm going to start with this curriculum. Then step by steps, we'll move inside our GenAI content, right? Fine, so let's move with this. So first we'll talk about this generative AI definition. If you see here, just now told you that generative AI means that is used to generate some content, that is used to create some content, create some image, create some audio, create some video, create some code, means generating some content. That is generative AI. We can define it like generative AI is a type of artificial intelligence technology that can produce various types of content, including text, image, audio, code, video, etc. Right? So let's start with this curriculum. First, we'll talk about AI/ML introduction. Some AI/ML introductions we should know before we come to generative AI. If you already know, it's fine, good. But purpose is that all the participants would be on the same page. So let's talk about some AI/ML introduction here. Now here, why AI or machine learning? Right? So if you see here, that we have to talk about first. So why machine learning or AI is a future? See, I've just shared with you a slide where you will find some details related to data growth. Today, in the year 2024, you can see we are dealing with the data in zettabyte scale. Zettabyte is a parameter that is used to deal big data. Big data means today we're going to deal with big data. Big data means the data that you cannot store with your traditional devices like your mobile or laptop. Neither you can analyze this. That is big data. So big data parameters, measurement parameters like zettabyte, brontobyte. Then we have parameters like petabyte. So data is measured in this. So today we are going to deal with big data. If you go with our smart cities, if you go with our medical industry, go with our e-commerce, social media, you'll find continuous flow of data. It is generated continuously. And what business is doing? Business is going to store this data, is going to analyze the data and take a business decisions. So in today's business is going to deal with the data. The business is going to deal with the big data. That is not at all possible to deal with human mind or human mind basic capabilities. Right? So what you're talking about is that it is almost impossible to deal with this much of data with traditional means of hardware and software. Where machine learning will help us to understand the data as well as to take intelligent business decisions. And you will find 90% of today's data is produced in last 10 years. And you'll get an idea about this huge amount of data that you'll find from various industries. Like these are the different industries: industry in the biotech side, industry in healthcare, automobile, manufacturing, telecom, social media. You'll find these are the various industries where you'll find they're going to generate huge amount of data. Right now, the point is that you're talking about these are the ML applications like self-driving car, product recommendation system, Uber face recognition, Google Home, Netflix movie recommendation, Siri in Apple iPhone. Right? So these are the products that industry is using today, and they are using ML or machine learning. Now, the point is that then what are the benefits of machine learning? Using machine learning, it will help us to take faster decisions. Machine learning develop insights that are beyond human capabilities. It act at the right time and take advantage of the opportunities, converting them into a closed deals. It has an impact on revenue and profit of the company. So machine learning can analyze huge amount of data, can analyze big data that basic human being cannot do, right? So that's why you're moving towards machine learning, right? So businesses are analyzing this huge amount of data and taking a business decisions, and that business decisions, right, is used to take to move towards business growth. Now here we are talking about first how you can define machine learning, right? How you can define machine learning? If you want to define machine learning, you can say that it is a subfield of computer science that will give a computer the ability to learn without being explicitly programmed. So you can say like that, it's a subfield of computer science that will give the computer the ability to learn without being explicitly programmed. Now the question is, how computer learn? So it is similar to human being. How human being learn? Same like that computer also learn. So how it is? Let's explore more. What machine learning does? It finds the patterns in the data, uses those patterns to predict the future. So let's explore some examples, like we can do, or we can detect credit card fraud. We can determine whether a customer is likely to switch to a competitor. We can decide if customer loan will be approved or not. These are some of the tasks that we can very easily do with the help of machine learning. Let's explore more. What does it mean by learn? Just now I'm saying that machine will learn as human being learn. What does it mean by learn? How did you learn to read? Identifying a pattern. So recognizing those patterns when you see them again So if you see here, see human behavior is hugely dependent on the events of the past. Similarly, machine algo depends on the extraction of knowledge from the past data. See here, if you show some fruits first time to a kid, he or she cannot understand it. But if you tell like it's an apple, second time or third time, you'll get it. That means that the brain has identified various points associated with the fruits and can understand the difference between different fruit size also. Right? So when we label it as it is an apple or orange, then the brain assigns those labels based on those data points. This is how we identify, we learn, right? Identifying a pattern. Now, if you see here, let us give some example of sample data, sample example, how we can identify a pattern in the data. Now, in this example, if you see here, we have been given some sample examples of loan data. Customer details are there. If you see here, if you just see here that this is the details of the customer loan details in a particular organization, particular bank. Now here, this is a loan ID, gender, married or not, dependents, education. Like this way, multiple parameters are there. Then you'll find here loan status. So if you just analyze this data, you'll find here we have different two category of variables. This category of variables are called independent variables. Loan ID, gender, married, co-applicant, credit history, property area. These are called independent variables. Whereas this parameter, loan status, is called dependent variables. Because based on this input parameter, I am going to decide whether the loan will be approved or not. So this is for him, loan is approved. For him, loan is not approved. That is being defined with the help of yes or no. So these variables are called independent variables, and this is called dependent variables. Now let's get some more info, more idea about this data. If you see here, loan ID, gender, married, self-employed, these are the properties, these are all string type, right? Whereas if you see dependents, then if you see here, income, loan amount, credit history, these are numeric parameters, right? If you analyze very carefully this data, you'll find that some of the variables like gender, see here, male, female, some of the variables like married, like yes or no, right? If you see here, some of the variables like self-employed, yes or no. So some of the parameter is coming in the format of 0 and 1, either yes or no, right? So these are called categorical variables. Whereas dependents 0, 1, 2, they are called continuous variables. Income, loan amount, term, continuous variables. So when I'm going to analyze the data, we should have the idea about this. Especially these are called independent variables, and loan status, it is called dependent variables, right? So this is the data that we can represent in a relational table format, right? Now you can see another category of data here. This is an image. This is an image. Now, from human mind point of view, very easily you can say that this is a smiling face, this is an angry face. But how you want machine to identify that this is a smiling face, this is an angry face? We have to identify features and put all those details inside an ML algo. An ML algo will decide whether it is a smiling face or angry face, right? So you can see here, we can have the data that is we can represent in relational format. We can have some data that we can analyze or machine can analyze that is in the form of image, non-relational, right? So the point is that ML can identify pattern from the data that is in relational format. ML can identifying the pattern from the data that is in image format, right? Now you can see here in machine learning, what you have to do, your data can be in relational format or your data can be in um, image format, right? Whatever the data it is, your machine learning algorithm identify the pattern inside the data and create a model. Once this model is trained with huge amount of data, then you can use this model to predict whether a particular person loan will be approved or not. This is one type of prediction you can apply, right? So this is how, in case of machine learning, it is used to identify the pattern in the data and create a model. Then once the model is trained with huge amount of data, then you can use that model for prediction. This is what we do in machine learning, right? Now here, why AI or machine learning is so hot right now, right? So doing machine learning well requires lots of data because you have to train the model with huge amount of data. Else you'll not get correct prediction, right? Then lots of compute power required. Then we need effective machine learning algo, right? So these are some of the things that we need. Now, a closer look inside machine learning, what you find is that you have to train, you should have a training data, means if you should train the model, you should test the model, then we should use that particular model for prediction. That we do in our traditional machine learning. Now, this machine learning that we talked about here, this can be categorized into two parts. One is called supervised learning, another is called unsupervised learning. So we should have some idea about, yes, machine learning mainly used to do the prediction. Using machine learning, we can do some prediction with that particular model that we trained based on huge amount of data. That data can be a relational or that data can be some image. Now, this machine learning is categorized into two types. One is called supervised learning, another is called unsupervised learning. So let's understand first, what does it mean by supervised learning? It is one type of machine learning. See, supervised learning, where input and output both is given to us. Just see this diagram, it will give you the idea. Where input and output both is given to us. If you see here that in this diagram, we have been given the year of experience and the salary. As the number of year of experience will increase, you can see the corresponding salary is also given to us. So input and output both is given. In case of supervised learning, input and output both is given. And what we have to do is that once we build a model, and that model can do some prediction, like what should be the salary of an employee who have experience of 8.5 years, right? Like this, right? So using the supervised learning, we can do some prediction, right? Now, right, we can do some prediction in case of supervised learning, right? So the point is that in case of supervised learning, we have been given input and output both. So supervised learning is a type of machine learning used to learn models from leveled training data. It allows us to predict output for future or unseen data. So this is one example of supervised learning. Now, the supervised learning is divided into two categories. One is called classification. So what is the classification type supervised learning? What we do here is that we divide the data into binary. Means the scenario. Let me give an example. Like based on the past data, we are going to predict if the person is eligible for a loan or not. So what you do is that you're going to classify either the person is eligible for note, yes, or he is not eligible for loan, no. So you are going to define the output in the format of 0 and 1 or true or false. That type of machine supervised learning is called classification. So see this example here. Here, what you are going to do, once the model is trained, when you have created the model, then you are using this model to predict if the loan will be approved or not for a particular customer. So either it will be approved or it will not be approved. So you're getting an answer with 0 and 1 or true or false, right? So this type of machine learning where you're going to predict in 0 and 1 or true or false is called supervised learning, right? Next, if you see supervised learning classification type, another type of supervised learning that is called regression. So regression means what? Based on the info, you can predict the price of a particular flat. Based on the info, you're going to predict what should be the employee salary whose experience is 15 years. This comes under regression. So in case of regression, this is an example of regression. Means based on the info, you are going to predict the employee salary. It is not coming in as 0 and 1 or true and false. Supervised classification output is coming as 0 and 1 or true or false. But supervised regression, how you are going to predict, right? Some value, like predict the employee salary based on the experience, predict the price of a particular flat or plot, right? This type of example comes under regression, supervised learning, right? Next, you are talking about another type of machine learning that is called unsupervised learning. What is unsupervised learning? In case of supervised learning, you know input and output both. Whereas in case of unsupervised learning, you know input, but you don't know the output. Means we know the input, but we don't know the output. As for example, just see this example, then it will give us the idea. If you see here, If you see this diagram, in this diagram, you see here that the annual income is given as well as the spending score is also given for the customer. Now, these are the category of customer whose annual income is high, but spending score is less, right? These are the category of the customer whose annual income is less, but the spending score is high, right? Whereas these are the category of the customer, you can see they have a medium annual income, but they have very high spending score. So the sales team or marketing team always try to use this category of customer. They try to send a mail or they want to communicate with this category of customer because there is much more probability to get the lead, right? So this is what we have been given input, and based on the input you are going to predict the output. Output is not given. We're going to predict those customers who have high spending score as well as high income. So because we can get higher leads from them. So this comes under unsupervised learning. That's what we're talking about here. Unsupervised learning is a subset of machine learning, and it is used to extract, inferences from data sets, that consist of input data without labeled response. Means we have been given input, but we don't know the output, right? That comes under unsupervised learning. So these unsupervised learnings are also two types. One is called clustering, another is called association. So what you do in the clustering, just now given the example, the most common unsupervised learning method is a cluster analysis. It is used to find data cluster so that each cluster has the most closely matched data. For example, based on the customer annual income and spending score, we send them the email notifications. Just now they have shown the example of clustering, right? Same like that, associations. Association is another type of unsupervised learning. What we find in association, assume like customer, assume you buy some product from Amazon regularly. So automatically Amazon have a customer set, customer details, right? Now, whenever you're going to log in Amazon.com, what they do is that based on the past buying details, Amazon will recommend the similar type of product to you. This comes under association, right? So this association and clustering both comes under unsupervised learning, machine learning, right? So what you find here is that we have two types of machine learning: unsupervised learning and supervised learning. Now the point is that we can use this machine learning. Business is using machine learning. Especially if you see this diagram just now told you that the business that is using machine learning, these are the business that is using machine learning today. These are the business that using machine learning today. Just now told you, right? Examples of ML applications. But they are not, these businesses, they are not using actually basic machine learning or traditional machine learning. These businesses, they are using deep learning, not the traditional machine learning. Right? If you think about our topic is generative AI, right? So generative AI internally also using deep learning. Right? So we should have very good understanding about deep learning in the next step. We talked about here, you can see, yes, we are talking about this part. If you see this, that we should have some introduction about AI and ML. Now I'm talking about deep learning. Because this AI and ML is fine from a learning point of view, but business never use basic ML because basic ML will not give us good prediction. A better prediction or accuracy, we should always go for deep learning. Right? So our next topic is that we should learn deep learning. Right? So let's understand this deep learning in the next step. Right? So okay, so let's move with the deep learning side. Now see here. Now our topic is deep learning. Now we should know that what is this deep learning? How we can differentiate deep learning with traditional machine learning. Right? The difference, we should have clear difference idea, right? Because our Gen AI or generative AI internally is using deep learning. Right? So before coming to generative AI, we should have some good understanding about deep learning. Right? So let's talk about it. Let's understand about deep learning. See, when I say deep learning, deep learning does not, mean that machine learns more into depth knowledge. What does it mean by deep learning? Let's explore. See, if you see this diagram, this will give you a good idea. First, I'm talking about artificial intelligence. So this artificial intelligence, you can see, is technique which enable machines to mimic human behavior. So machine learning is the subset of artificial intelligence. So this machine learning is an art, a study of algorithm that learns from the example and experience. In case of machine learning, you're going to find the pattern in the data. Then you build a model, and this model is used for prediction. Now I'm talking about this deep learning. If you see here, this deep learning is a subset of machine learning. It's a subfield of machine learning. Now, when I say deep learning, it doesn't mean that the machine learns more in-depth knowledge. It means the machine uses different layers to learn from the data. The depth of the model is represented by the number of layers in the model. For instance, Google LeNet model for image recognition, they have 22 layers. Let's understand more into this. Just see this diagram, how we can differentiate these two, ML and deep learning. See, you have some data, you extract the features, and then you find the pattern from the data, and you build a model, and this model is going to predict if it is a car or bike. But what happened in deep learning? Same things. You have the input data, you'll extract the features, then you train the models, and that model is used to predict whether it is a car or not. Then what is the difference between machine learning and deep learning? How you can differentiate between them? The difference is that in case of deep learning, it uses different layers to learn from the data. The depth of the model is represented by number of layers. Whereas in case of traditional machine learning, it is going to find the pattern in the data, create a model, and that model is going for prediction. Whereas in case of deep learning, machine uses different layers that is called neural network. It uses different layers, neural network layers, to learn from the data, right? So in deep learning, the learning phase is done through a neural network. Okay. So neural network is an architecture where the layers are stacked on top of each other, right? So when we talked about deep learning, the model is created internally using neural networks. It's a core. So when I say that generative AI, internally it is using multiple deep learnings. So deep learning core concept is artificial neural network. It uses neural network to train the model and to do the prediction. Right? That's the difference. When I'm moving from machine learning to deep learning, what is the difference that you're talking about here? Right? And all the businesses, they never use basic machine learning. They always use deep learning. All the business that you find AML industry. Right? So let's move toward this deep learning side. Now here you can see what is deep learning. Right? Now here, deep learning is a machine learning techniques. Just now I talked about. It's a subfield of machine learning. So it's a machine learning technique that learns features and tasks directly from the data, where the data may be image, text, or sound. Right? Now the point is that and that factors that make deep learning different. We are saying that traditional business, they never use machine learning, they use deep learning, right? So what are the how we can differentiate deep learning from a traditional machine learning that you're talking about here? Factors that make deep learning different. What are those factors? Just see your first point, it's an unique. Unique means it can work directly on digital representation of data, such that image, video, and audio. See, traditional machine learning must pre-process the data in some way, and the data scientist has to tell the algorithm that what to look for. Data scientists mainly identify the features. But in case of deep learning, feature engineering is built in. Automatically features is extracted. That is, it's an unique. Second point is that just now told you feature engineering is built in. You don't need data scientists to identify the features, and then you will use those features, apply the algorithm, and move next step. In case of deep learning, feature engineering is built in. Deep learning tries to circumvent the challenges with automatic feature extraction. Deep learning models are capable of learning to focus on the right features by themselves, requiring little guidance from the programmer. That is one of the important features of deep learning. Another one very important features is that supercomputers are required. Now, what is the supercomputer? You know that the unique characteristics of deep learning is that, the training process. Okay, the training process involves mathematical vector operations, that often results in the need of billions of computations. Now, to meet that need for affordable supercomputer power, deep learning researchers created the GPU, graphical processing unit, because they have thousands of cores and perform the operations necessary to train deep learning network. This NVIDIA, you're familiar with the company? NVIDIA is the best known GPU maker that design, develop, and market deep learning GPU systems that support popular open source deep learning libraries. Now, lots of company came in the market. NVIDIA is the top, but lots of companies step by step is coming in the market who can create GPUs so that we can train our algorithm with billions of parameters, right? So, right, that is another one important. When you go for deep learning, the supercomputers are required. Next is that the open source libraries. Means what? See, if you go with deep learning, you'll find these are some of the algorithms like ANN, artificial neural network, CNN, convolutional neural network, NLP, natural language processing, CAFE, deep learning 4J, MXNet, TensorFlow, Theano. These are the open source libraries. If you want to create a deep learning model, you need these libraries. These libraries can very well, these are open source, and you can use Python to use these libraries to create your deep learning models, so that you don't have to depends on a specific vendor. There are open source libraries that you can use them, you can build your deep learning model, and you can do prediction, right? So these are the advantage. These are the factors that make deep learning different. Since you are training the model with billions of parameters with open source libraries, so automatically, right, companies are getting very high prediction. All businesses today using deep learning for their prediction, right? So that you're talking about here. Now, our focus is to understand the deep learning because our GenAI internal architecture, you'll find that it is using deep learning models, right? So before coming to the GenAI, you should have a good understanding about this deep learning, how it works, deep learning, how it is going to do the prediction. We should have some good understanding. If you're going in the core developer side, we have a very good understanding, right? So let's understand this first. Next, we'll move to the GenAI side. So here you can see that just now told you that deep learning is a subset of machine learning. Deep learning use artificial neural network, right? Deep learning can predict if the input is a dog image, then the result will be a dog pic, right? So we're talking about that. The core of the deep learning is artificial neural network, or ANN. How deep learning work, if you want to know, then we should have a very good understanding about ANN. If you know how ANN is working, you got the full idea of deep learning. got the full idea about deep learning, how deep learning work. Right? So our focus is to understand this artificial neural network. Try to understand this. So let's see here, just see. You go with artificial neural network, we should know first about this neuron. Now, see how human brain learn. We want in the same way machine to learn. See how human brain learn with the help of neuron. With the help of neuron, human brain learn. Right. So we want in the same way machine should learn using neuron. That means human being learn with the help of neuron, and that is with them already. But we want machine to learn using neuron. That means what? We have to recreate the neuron for the machine, because machine does not have neuron, right? Human have neurons. Human learn with the help of neuron. In artificial neural network, what we will do is that we want machine should learn using neuron. So if you want machine should learn using neuron, we have to create the neuron for the machine. Means we want to recreate neurons. Right? So that you're talking about here. If you see this here, see neuron by itself no use. It look like this. Dendrites are the receiver of signal. Actions are the transmitter of signals. Dendrites are connected with action of the other neuron. Dendrite do not connect to action. They just exchange the signal, and between them that connection is called synapse. So here, if you see this input layer is sensor. It's called sensor. Now see here, the circles. These are circles, right? You can see here. So these circles are, you can say these circles are neurons or nodes. So each column is called a layer. 1, 2, 3, 4. The first layer is called the input layer. Then all the layers between the input layer are called the hidden layers. Now this is the output layer. Now here, if you have one or few hidden layers, then we say it is a swallow neural network. If you have many hidden layers, then we define it as a deep neural network. So in this model, you have input data. You can weight it and pass it through the function to the neuron. Now see here, you get an idea. You will get this idea well. If you see here, in this example, like, see, the brain is like a black box, and the electrical signals is coming inside the box. Think about this input values. See, if you remember, we talked about the the relational data where we have independent variables and dependent variables related to customer. Independent variables means customer married status, customer dependence, customer credit score, all are independent variables. Dependent variables means whether the loan will be approved or not. That I'm talking about. All the independent variables will be on the left side, and independent variables whether it will be approved or not. right? So if you can see here that these input values are nothing but your independent variables. The independent variables are one single observations. Output variables can be binary value or categorical value or continuous value, right? So the weights you can see here, you have written summation wi xi. Xi is the independent variables and the weights. So weights are crucial to an artificial neural network. Weights are how neural network learn. So adjusting the weights, ANN decide the every single case. So weights are get adjusted through the process of learning. So what happened inside the neuron? It add all input values with the weights. How it is? If you can see here, we're talking about how neural network work and the back propagation in deep learning. If you see here, that we have to adjust the output value. You can see here in this example, just see this example, I think it will give you the correct. If you see in this example, all input values can connect with the top neurons using synapse. Those synapses have weights. See, some weights have non-zero or zero values. In this example, see, out of 4 inputs, assume x1 and x3 input focus the first neuron. Assume x1, x4 and x5 focus the second neuron. Assume x1 and x5 focus the third neuron. Hidden layer neurons, should have picked up, some input, that we have not yet thought of. As for example, see, these are the input variables like area, bedrooms, distance to the city, age. These are the input variables to predict the price of the flat. So assume these are the input variables, and this is the already model is there. When you're passing these input variables, it is going to predict the price. Output variable is what's the price of the flat or plot based on these input parameters, right? So the question is that how neural network learn? It has a multiple layers. We have an input layers, it has an output layers, multiple hidden layers. If we have multiple hidden layers, we say it is a artificial neural network. Now the question is that how neural network learn? That is the topic. Right now here, now if you see in this diagram, if you can see here, just see this diagram, it will give you the actual idea. See here, these are the input variable parameters we have given. We have to adjust the output value, that is the predicted value. Since y is the actual value, so let's input value is fed in the neuron that have some activation function. We'll apply here and we'll get the output. So then, what we'll do is that we will plot the output inside the chart. Okay, so in order to neural network learn, we have to compare output value with the actual values. Cost function can be calculated based on that. The difference between the output actual value and the output values. So cost function, sometimes we say that it will tell the error, and right. So our goal is to minimize the cost function. So what we say is that, the lower the cost function, the closer the output and the actual, right? So once we compare them, we feed this information back in the neural network, and information is going back to neural network, and it goes to weights. The weights gets updated. So our goal is to minimize the cost function, so we can do is to update the weights. Now see, this is the scenario, one scenario. See, scenario is that one student who studied 12 hours, sleep 6 hours. In the quiz, he got 78% marks. They're the independent variables. If these are the independent variables, means you're going to give the input from here. And dependent variables is what is his probability to pass the exam? 93%. So these are the independent variables, these are dependent variables. Right? Think about this scenario. So what you're talking about here is that we are dealing with only one row. Right? So you can see here, right? We have given some input. If we have given some input, we get the output value, cost function gets adjusted, and we feed this information back inside the neuron. So it goes to weights, and weights gets updated. So output value gets updated. So we continue this process till the time cost function is going to 0. See here, this is for one row. Similarly, if I have an 8 rows, for each row there is one neural network. So for 8 rows, there should be an 8 neural network, and there should be an 8 cost function values. So that means for each row we have one neural network and one output values. So for 8 rows, we have 8 neural network and 8 output values and 8 actual values. Right? So then we calculate the cost function based on the actual and output values. Right? So similar, actually the scenario is that, what you do, we think about all these 8 neural network as a single neural network. We want to create an ANN that will learn on its own, and our goal is to minimize the cost function so that we can get actual prediction, actual probability. Right? So here you'll find one concept is called gradient descent. Gradient descent is an optimization technique that is used to improve deep learning and neural network based models to minimize the cost function. So it will give us the proper prediction with the help of gradient descent. You can see here, this diagram, it will tell you this is the actual values, this is the accurate values, and this is the cost function. So our focus is to minimize the cost function for a particular actual values, for a particular value, right? So our focus is to minimize the cost function, right? That we can define with the brute force algorithm in case of artificial neural network. And that minimized value we generally define with the help of gradient descent. Gradient descent will tell you the actual value, uh, right? The actual accurate value based on the less cost function. So these are the things that there in case of artificial neural network. Purpose is to get accurate prediction with the of artificial neural network, training the data with using huge amount of data using artificial neural network. multiple layers. Now there is lots of things we are not going to implement a prediction, but we should have some idea. Yes, this is how deep learning will work. Where we are going to use this ANN. Now we came towards generative AI. Now we'll say that this generative AI, how we can differentiate generative AI with deep learning. Yes, we are saying that yes, generative AI internally used is using deep learning only. Let's get some information more into this. Now, if you can see here, what is this generative AI? You see, it's a subset of deep learning model. Okay, now it is used to generate content. Just now we told you, purpose of generative AI is to generate some content. Generate some image, generate some code, generate some video, audio, generate some text. We use generative AI. Now it is used to generate new content. Examples of GenAI is LLM and LMM. We'll talk about it. What is LLM? So just for the time, just remember LLM and LMM. These are the examples of GenAI. I'm coming into that. Now see, here is that let us first talk about the definition of GenAI. It's a type of artificial intelligence that create new content based on what it has learned from the existing content, how it is being trained. Learning from existing content, GenAI model is created. Based on the prompt, GenAI use the model to predict. Right? I'll talk about what is prompt. I'm coming into this. Now, what is our first requirement is that how we can difference GenAI and deep learning model. How we can differentiate? See here. Just now told you that we know about some deep learnings like LLM, like our ANN, CNN, NLP. These are the deep learning model, RNN. So purpose of deep learning model is used to do some prediction. Whereas generative AI is going to create a new content. Let's understand this using some example. I'm just talking about, I'm writing here some topic like, I'm just talking about difference between deep learning and generative AI. Generative AI. We should have a good understanding about this. Let's understand. See, this is our artificial intelligence. We already talked about it. So you can just write here AI or artificial intelligence. Inside AI, we talked about we have machine learning, right? So let me move it slide up. Right now here inside this AI, I'm just going to create another one diagram. Assume this is machine learning. Right? So inside AI, we have ML or machine learning. So let me just write here. ML. Inside ML, we talked about deep learning. So this is the deep learning. Right? So assume I'm just writing a deep learning. Deep learning, right? Now this deep learning, inside this there is two types of deep learning. One is called, let me just write, one is called discriminative deep learning. Another is called generative deep learning. Two types of deep learning is there. One is called discriminative, another is called generative. So I'm just writing here, this is called discriminative deep learning. Okay, and this is called generative deep learning. Or that I'm talking about generative AI, right? Generative deep learning. So there is two types of deep learning, discriminative and generative. So what is the purpose of this discriminative? Examples of discriminative deep learning, already talked about it, like our ANN, artificial neural network. Discriminative. CNN, convolutional neural network. Then we have NLP. Then we have RNN. These are the deep learning models. Okay, these are the deep learning models. Whereas in case of generative, we have, in case of generative AI, we have LLM, LMM. They are the examples of generative AI. Now, how we can differentiate more? Like they used to classify or predict. Okay, if you want to create another one text, you can just write discriminative. What they do is that used to classify or predict. What about the generative? They're used to generate content. Okay, so generate new data. So if you want to write here, you can write like this. Control Z. Okay, you can just write generate new data. Generate new data. Right? So this is the difference between discriminative deep learning and the generative deep learning. Right? So when talking about this deep learning, so classify, discriminative deep learning is used to classify or predict means whether the particular image is a dog image or cat image. We can do it. See, deep learning is also supervised and unsupervised. You know, you can predict whether the person loan will be approved or not. That is supervised learning classification. What should be the salary of an employee whose experience is 12 years? That is supervised regression, right? As well as unsupervised clustering, as well as association. These are, we can implement this machine learning using deep learning also, because deep learning can also be supervised and unsupervised. But they are going to predict. You are using this deep learning model for prediction, whereas generative AI is used to create a new data, right? That you are talking about in this example. So if you see here, in this example, we talked about Chat GPT. Now here we talked about two things. One is called LLM, another is called LMM. I'm coming into that. So before knowing this Chat GPT, we should have a good understanding about what does it mean by LLM, what does it mean by LMM. If you see here, we are talking about this generative AI part of LLM and LMM. Let's understand what is this LLM and LMM, right? So let me create another one, a file, new. You can save this one, save it. And I'm going to create a new file. So if you want to create a new file, you can just go to file. There is some option called new or rename, make a copy, or you can go down, no issues. Just go down. I can create another one topic just now told you. That is, I'm talking about the difference between, I'm saying that generative AI, you'll find two things. One is called LLM and it's called LMM. We should have the proper difference between these two terms. What does it mean by LLM and LMM? Right? So let's talk about it. First, we'll talk about. First, we'll talk about. Let's talk about it. Here in the left side, we'll talk about LLM. On the right side, we'll talk about LLM. Right? Fine. So here, just write LLM. Its full name is large language model. Large language model is the full name of LLM. Okay. Whereas LMM, its full name is LMM. Its full name is large multimodal. Large multimodal. That is LLM. What is the difference? If you are saying that generative AIs are LLM and LMM type. So what is the difference is that when I say, let me take the example first. Examples of LLM. Example is our OpenAI created Chat GPT. Chat GPT 3.5. You can think about this is an examples of LLM. Let me give an example first, and I'm coming. And examples of there is multiple examples. I'm just starting our discussion using this. Examples of LMM. Example is our Chat GPT 4. Chat GPT. It's an examples of LMM. Now see, we are talking about generative AI that is used to generate some content. So this Chat GPT 3.5 and 4, it is used to generate some content. It is one type of LLM. 3.5 is an LLM and 4 is LMM. Now the question is, what is the difference? Right? How you can differentiate between these two? Right? So let me just talk about here. In case of LM, input is a text and output is a text. So let me just check. Here I'm talking about input is text and output is also text. Input and output. Output is also a text that talking about. When giving some input and you'll get some output. So based on your input, you'll get some output. So input is a text as well as output is also a text. Whereas in case of LLM, let me just write. In case of LLM, I'm writing input. Input can be text, image, audio, video. Whereas output can be same text, image, audio, video. Right? So that is the scenario that you're talking about here. Right? So input can be a text, image, audio, video. Output can be text, image, audio, video in case of LMM. Right? So let's see how it is, how it work. Right? So, right now, let me give some example how it work. Right? So that you have given here, that Chat GPT, it is an one type of LLM where input is a text and output is a text. Right? Generative AI solution from OpenAI. So it is a see, there is multiple LLMs. I'm coming into that, but currently I'm just starting our discussions with this popular LLM called ChatGPT. Okay, so we can see, how we can use an LLM like ChatGPT, okay, to just to check, how it you can work with an LLM like ChatGPT. It is an LLM, means if you give some input as a text, it will give us an output as a text. Right? So if I'm going to work with this LLM, I have to go inside this URL. Right? So let's go inside this URL, Control C. So I'm going inside this URL, Control V, enter. So if you're doing it first time, you need to do some registration. For me, already I have registered. Right? So that's why I don't need any registration. I have already registered and logged in, done before starting our session. Now here, this is ChatGPT. You can see when I'm giving some input, I got some output. It is one type of LLM. It is one type of generative AI. Now, right here, the meaning of life is, just see here, it is giving us some text. So based on your input text, you're getting some output text. You have given some input text. Based on that, you got some output text. So based on text, you are getting some text that you're talking about. Input is a text, output is a text. It is ChatGPT 3.5. Whereas ChatGPT 4, input can be a text, image, audio, video. Output can be a text, image, audio, video. See here, this chat. If you see the ChatGPT 4, but it is not freely available. You have to take a subscription. Whereas ChatGPT 3.5, it's free, right? So that you're talking about here. Now the question is that if you're going to work with ChatGPT like LLM, you can use this. Now I'm just talking about how to work with this ChatGPT. Let's understand this LLM. Like, see, let me just talk about some points about this ChatGPT. See, this ChatGPT where you can query about any HR domain, medical domain, banking domain, or any applications that can be automated. It is an AI chatbot developed by OpenAI and built on top of OpenAI ChatGPT 3. Now here, 3.5 it's free, 4.0 is not free. Just now I've given one example, right? So lots of tasks you can automate it using this ChatGPT, right? Now here, this is one example of GenAI created by OpenAI, right? Now what we talked about this ChatGPT, let's see how to work with this ChatGPT. Okay, see this ChatGPT 3.5, it was actually trained till the data till 2021. Okay, so let's get some question like create a list of GCP. Let's see, I'm going for GCP individual layer certification. So I need to do some practice with the MCQ questions, right? So that's I'm create a list of GCP digital leader certification. So here, as you, I'm just writing here, create a list of digital leader certification. MCQ question, MCQ questions and answers. Okay. For software cloud developer, software cloud developer, using the rating scale of 1 to 5. Using the rating scale of 1 to 5. So you can see I'm writing a prompt. This is called prompt, the input that you're giving to ChatGPT. And based on your input, it is generating a text. See, text to text based. It is text to text based. That's why we say it is an LLM. And it's given us some questions that you can try. Total 10 questions generated give. Right? Just I want to show you that how this LLM is helpful to you as an employee in a particular specific domain of business. As for example, assume you are staying in a, let me give some scenario. You are staying in a apartment and you have been selected as the president in that apartment, and you communicate with different residents via email. You're staying in that particular apartment, right? So no, you have to send a mail, to all the residents related to some changes or related to some survey about a festival, right? So how to write that mail? You can generate the complete mail using ChatGPT LLM. How? Just see here. Write a mail. Write an email to society people. Society people that promote or link to society engagement, that promote or link or society engagement for festival survey. So for festival survey, asking them to fill out, within next 2 weeks. Asking them to fill out within next 2 weeks, right? Let me check. See here. And you can see it's giving us a very good and excellent mail communication that you can use with your residents who are staying, just to communicate with them, and that is generated as a text, right? Based on your input text. So it's a text to text based, right? Let me give another one scenario. Assume that your driver is not coming, missed his work for several days without any notice, and you want to send an email to your driver so that, with an intention to get him back to work, So how you can generate that mail using ChatGPT, right? So let me write another one prompt, like your driver has missed his work, missed his work for several days. Okay. So without notice, right? So please write an email with an intention. Please write an email with an intention to get him back to work. To get him back to work. Let me check what is the response from the ChatGPT. See here, it is coming with a response, and you can use a very good mail that you can use to communicate with your driver, right? So you can see in a fraction of a second, it is generating a mail, and this is what? This is your text to text based, right? So it's working fine, right? So so this is one LLM based on your input text. It is returning one text, right? Fine. So you can see what we have done.